You gotta try at least, right? So it was really nice that I got to talk to everybody a little bit, so I kind of have an idea of where everybody's at. But the topic for today's presentation is end-to-end testing immutable infrastructure. We're going to be deploying into Azure, so let's get going. All right. So I was working for a previous employer, and I was new to the company, and they gave me as my first app the kind of app that everybody likes to work with. It was a monolith with 7 different binaries. Half of them were in Java, half of them were in C, so I had multiple runtime environments to manage. On top of that, a database and all this obnoxious stuff to try and coordinate just for one application. That's a complicated app. Probably some of you have heard of it. It's called Every Application from the early 2000s. I see some head nods, so people have been there with me. Bravo. So I was brought into this company that I was working for at the time because I was a configuration management expert, whatever that means for, a guy just out of college with 2 years experience with Ansible. And when I was given this app, I did what a lot of us that are familiar with config management do. We write our roles. We make sure that our roles are working by running them 50 times in different sandbox environments and making sure that our services are working, stuff like that. And then, after I felt pretty confident, we started deploying our application to our different environments. We had 6 different environments to run through. And I mean it. Dev, QA, UAT, test, performance test, and then production. So it was quite a bit of work. But as we started rolling along, surprisingly, it was going really well. It was going so well that somehow I managed to convince my manager that I should be allowed to go to a conference the week of our production deployment. Not really sure how I got to do that, but anyways. So there I was, sitting in a conference that cost my company about $3 grand to send me to, and I get a phone call. The Ansible playbooks had worked, run successfully, but the services weren't starting. And there I was, 3,000 miles away, in a loud and crowded conference on shared Wi-Fi on the Zoom meeting. Can anybody here relate to that story at all?
Yeah.
Probably not the conference bit. I'm sure that was just a horrible decision, but anyways, take that story and pop it in the back of your mind. We'll come back to it in a little while. So, who is this insanely manipulative engineer that convinces manager of such a horrible decision? Hi, that's me, I'm Drew. I'm a senior cloud engineer at Nebulaworks, as I mentioned. And I have degrees from the Rochester Institute of Technology, MBA certificate from the Kelley School of Business at Indiana University. I am a Red Hat certified sysadmin. I am certified in Kubernetes. And I'm a huge believer in open source. If you're around me at all, you'll hear me talk a lot about open source. Anybody in our company really, you'll hear us talk about open source. I've contributed directly to Ansible. I am a maintainer for the HashiCorp Vault Python client called HVAC. That's what this little gray symbol is that I'm sure everybody's very familiar with. And I live happily here in Apex, North Carolina with my wife and our 2 kids who, thank God, look a lot more like her than me. So, today we're here to talk about testing infrastructure. So we're going to talk about, we're going to do a little tell and show. We'll start with the why and the what of testing, and then we'll get into the how, do some demos, hopefully have some time for questions at the end. So when I was designing this presentation, I was hoping that people would come in with some knowledge of config management, Ansible, Chef, whatever, some familiarity with it. I was hoping that you're deploying infrastructure as code already, or you're at least pretty familiar with it. Hopefully you're using Packer, or you know how it works or what it does, and hopefully you're using Git. Now when I was talking to everybody, I know that some of those tools aren't exactly what people are using, so I'm going to try and change how some of these conversations go a little bit, that I'm going to, well, not conversations, I'm just going to talk at you. And but I think you'll all still get something out of this presentation today, because we're talking about testing and tools don't always matter. So let's focus on process and not specific to tools. And then I'm hoping that you know a little bit about continuous integration, Terraform, Vagrant, Azure, Immutable infrastructure. That last one is really nice because as you begin your testing journey, it leads you really nicely into immutable infrastructure, and there are huge benefits that you can gain from doing that. So, everybody in the room knows that software engineers have had unit testing, functional testing for a long time. But infrastructure testing, why do we need that? Sure, it's good for them, but I'm not convinced that it's something that we need. So let's talk about the why. And I don't mean what are the benefits. Often people talk about these are the benefits and they say that's the why. I don't think that's necessarily the way to do it. So at the heart of testing is a hard truth. Everything changes. Whether it's a bug fix or a new feature, your code base changes, and it changes constantly. How do you know that your changes aren't forking previously working code? The guy in the cubicle next to you just announced that he's leaving, and he's the only one that knows how to run the Phoenix application. How do you know how to take over someone else's responsibilities when your developers change? The library that your app relies upon just had a major update. When you install it, is it going to work with your app? Who knows? You see, all of these changes create chaos. Testing is about taking back control despite that chaos. A mentor of mine has a mantra. When your tests are good, your deployments are never scary. And he's right. A well-written test base gives you a peace of mind that will literally help you sleep better at night. However, lastly, and perhaps most importantly, when you have these pipelines running, when you have your tests going, when you see these things run, you just get this feeling. Oh, you see those green check marks, and oh, it just gives you this good feeling. And it's really, it's honestly kind of an invigorating thing. You may call me a nerd, and you're definitely right. But it's cool to see the joy that perks up in my own heart when I see these things pass. So now, a slide for your boss. Dear Mr. Manager, why should you let your engineers spend up to 30% of their time writing tests when instead they could just log into the server after it's running and make sure that it's working? Well, many of you already know this, but any changes in your company that involve production infrastructure are 9 times out of 10 highly scrutinized events. I mean, these things take dozens of meetings, approvals from a cab, multiple project managers with multiple people overseeing the project plans, executive buy-in, and always a downtime, almost always a downtime, I should say. Needless to say, these are stressful events for everybody involved, except for maybe the application developers themselves. But testing will help you reduce your risk. Over time, as your test base grows, your deployment confidence will increase significantly. You'll have testing that will cover multiple scenarios, not only for your application, but for other people's applications that you can share. Or maybe they've already written tests that you can glean from. The development environments that we often have to provide, depending on what part of the field you're in, we're usually responsible for providing dev environments for app developers. Usually they call those prod 2, because if the dev environments are down, then our app developers can't do anything, and apparently all hell breaks loose. Well, automated testing makes it much easier for you to spin up and spin down development environments so that you can pass them off to your dev team and go about your business. Combined with infrastructure as code, testing as code documents the use cases and the infrastructure that you own in a way that can be understood and scrutinized and improved upon by every other developer in your organization. And lastly, is anybody in here afraid of tech debt? I definitely am. Michael is very afraid of tech debt. And that's wise, because tech debt is a real problem that threatens us every day. A solid test base makes it very easy for you to refactor your code. Now, what do I mean? So you have a function that works, and you know that when it gets these inputs, you get this output. Well, if you write a test that verifies that, now you can change this function as much as you need, and you can always verify it against the same test. So refactoring your code reduces your tech debt, makes it less scary to change the applications. I forget I was talking about scary servers with somebody. I think we were talking about that. Scary servers that nobody knows what they do. Well, there's scary applications out there too. Testing will help you not be so afraid. So next, we've talked about the why, right? We've talked about the why of testing. Why is it important? Why should we consider it? So let's take a second to consider some alternative presentation titles that I could have used, but Anne wouldn't let me.
Wow.
I'll let you read those. I'm just going to take a turn. So, there are 4 kinds of tests. But wait a second. We need to acknowledge somebody in the room. Who is it? It's you! Congratulations! You've already been testing. You've been testing using the first method that we're going to talk about. Well, what kind of method is that? Or what kind of testing? With the power of tribal knowledge and a wisdom that comes from being burned one too many times, you manually test known important configurations to ensure that your applications are deployed successfully. Woohoo! All right, let's go have a beer. We're done, right? I'm just kidding. You can subtract. You know I'm going to tell you 3 more. So let's talk a little bit about how we can start automating our tests, because this method has failed us more times than we care to admit, and that's why everybody's here in this room. So first we have linting. Linting is a syntax check that helps you ensure that your whole team is not pushing in ugly code that's hard to read. It also performs validation. So if you have a JSON file and you're missing a curly brace, linting is going to catch that for you before you waste a whole bunch of time pushing it out into your master branch. Unit testing and linting runs before any of your code runs. That's what I recommend. It's instant to calculate whether or not you're linted, so you run those before any of your infrastructure code runs. We'll see how that works in CI in a little while. Unit testing is, it also runs before your code. It's a way to test isolated functions using examples that you define yourself. When it comes to infrastructure unit testing, it gets a little weird, and it's a very new space. There's not a ton in this space yet, especially not for Azure, which is the cloud that I'm going to show you today. But an example of that might be you have a Terraform plan and you write it to a file, and you can have a tool like rspec Terraform or something like that validate that, that file. But finally, we have integration testing. Integration testing is the verification of the output from your code. So you run your Terraform or you run your deployment scripts. Did you get what you expected? Simple. That's what an integration test is. Today, we're going to be talking about linting and integration tests and how we can fit that into a workflow. I'll show you a good example. There's code that's published online with decent documentation. You can open issues, though, if you don't like it, and we can make improvements together. But also, as an honorable mention, there's a 5th kind of testing. Surprise! It's called policy testing. Policy testing is also very new, and it often involves different groups of people. So we knew that this was going to be heavy on DevOps people, maybe some app developers that are getting into DevOps today. Not that policy testing can't be used by people in DevOps, but it's usually more applicable for people in compliance. So we're not going to talk about that a little bit today. However, if you're interested, there's 2 tools that I recommend you take a look at. HashiCorp Sentinel is one, and the other is OPA, the Open Policy Agent. If you're interested in policy as code at all, you could also bring it up with me after this presentation. I would love to come do a presentation on policy as code if you're interested in that. So let's get into the meat. How does all this work? Well, I'm going to show you an example of how you can do this in a cloud environment. So there are different ways that you can do these things, and I would love your feedback if you're like, oh, why did you make that decision? Like, let's talk about it, let's argue about it, because I try to, we try to make sound decisions with some of our engineering architectures. So in this example, we're building VMs. Since we're cloud native here, we're constantly fighting to shift left, meaning move as much as possible as we can into our VM images themselves. That helps us with faster deployments. So instead of deploying a VM and then applying a ton of configuration after the fact, you can drastically reduce those deployment times by pushing that configuration into an image and pushing that out to the cloud. So we're going to do that today using Packer. So Packer is going to publish to Azure Cloud, and then Terraform is going to spin up hardware using that image. I'm guessing many of us here have seen that pattern already, Terraform image, Packer image Terraform. So what I'm going to do is I'm going to show you how you can inject testing into that process. And it's pretty cool, and it's not super complicated once you start seeing how it can work. But in order to create a Packer image in the first place, we have to develop one. So I'm going to show you an easy way that we can do it locally. Many people who are using Packer are used to seeing it done in the cloud. So you write an image, and then boom, it shoots it up to the cloud, and then you test it up there. But I'm going to show you how you can do it faster and a little bit easier, in my opinion, locally. So I'll show you an example of how to do that using Vagrant. And then we're going to move on to CI. So the CI files that we have, they define what kind of rigor we want to put around our code bases. So we're going to have CI files, pipelines rather, for both Terraform and our Packer code. We're going to have separate pipelines for both of those. Our Packer pipeline is going to start by linting our code, which we mentioned before. It's going to create the image, it's going to test the image, and then it's going to publish it to the cloud. Our Terraform pipeline will, again, lint. It will then build a separate environment using that code in a sandbox, and then we'll run tests against that environment. This is going to help us ensure that our code is working as we expect it. Sorry. So that's the middle part, CI. Yeah, go ahead.
Sorry, I may be down. Can you tell me what is Vagrant? I never use it.
Yeah, so
just said Packer is the configuration.
Yeah, thank you for asking. So there are tons of different hypervisors, right, that you can use. You can use like VMware or VirtualBox. Like there's tons of different ways that you can spin up VMs locally, right? So Vagrant is a way of abstracting. So like if you were going to write a VirtualBox ISO, it has its own configuration. Vagrant takes all the different hypervisors that you can use, and it just gives you one piece of code that you can write and then apply that to any hypervisor that you want. So you can easily spin up a VM in VirtualBox and then change it to another hypervisor if you need. Does that help?
So in runtime you can switch the hypervisors on VMs? We just
Not at runtime, but you can build images for other hypervisors using the Vagrant code. Yeah, sure. Good question.
It's the equivalent of Terraform for the cloud. Like Terraform in the cloud is what Vagrant is locally.
Yeah, that's a really good way to put it. I think that's a good, because Terraform helps you deploy to any cloud, right? Or be multi-cloud if you want. But Vagrant can help you locally deploy to any hypervisor. That's a really good way to put it. Thank you. So last but not least, in this pipeline, or in this design, we have tests that actually run locally on the box too. So after we go through the CI, after we go through our deployments, once we have VMs running in the cloud, we have tests that are running locally on a schedule, basically, on a systemd timer. And those test results are logged to our cloud provider. So when we do that, now it's very easy to have automated alerts based on if you have like some configuration drift, so a file gets changed somehow and you weren't expecting that and you need it to be there, you'll get alerted in the cloud based on stuff like that. So let's talk about testing tools. There are quite a few tools that you can choose from in the testing space. This is just a small sample. There are more, trust me. But here's some honorable mentions. First we have the specs, if you will. Starting with RSpec on the left. RSpec is the parent to both Inspec and ServerSpec. It's Ruby-based. All of those are Ruby-based. Next we have Gauss and TerraTest. Those are both written in Go. And then TestInfra on the bottom right is written in Python. So today we're going to be using Inspec. But one of the reasons that I mentioned this is that a lot of these tools are very interchangeable, especially if you're not familiar with one language, or if your app is written in one language, so you want to keep it in, if you want to keep your test written in the same language, you can swap all of this out with basically any of these tools. You might have to tweak some of the processes here, but you get the point. All these tools are available for you to use, And you're probably going to end up using multiple as your testing journey goes on because certain ones fit in certain situations better than others. So Inspec is a Ruby gem developed by Chef. It has native integrations with many tools that I personally care about, namely Packer, that we're going to talk about today, Ansible Molecule, which I almost talked about instead, is a really cool tool, Ansible Molecule. And then obviously, since it's developed by Chef, it fits in really well with the Chef suite. One of the nice things about Inspec also that it has that some of the other testing tools don't have is you can actually test cloud resources themselves. So instead of doing something like SSHing into a box and then verifying that you have a load balancer by checking the IP or something like that, you can actually just have Inspec test, say I have Azure load balancer named Unicorn project with port 1337 available on it, and Inspec can do that for you. It's pretty cool. So since we're talking about Inspec, let's do a quick primer on it. If you look at the right-hand side, that blue bubble, I don't know if you can tell it's blue because the light's kind of bad, but trust me, it's blue. That's a snippet of code. So the primary organizational object of Inspec is the profile. The profile is something that you're going to hear me talk a lot about today because that's how you organize your tests. Tests in Inspec are called controls. Controls are grouped, they can be grouped together, or they can just be single. If you look in the green there, that's called a resource. Resources verify properties of an instance or a thing that you're trying to test, a thing, if you will. You usually pair those up with a matcher, that's what's in the gray right there. So it's pretty easy to read this test that we have here, I think. Describe the file /temp. It should be a directory. That's one thing that's great about this. It's not rocket science. As long as you can read, you can understand what these things are. And pretty much all of these test frameworks that I mentioned before are this way. That's not completely true, but it is mostly true. Inspec also has the idea of targets. Targets are a way of telling Inspec how you're going to authenticate to what you're trying to hit. So if it's a VM that you want to run tests on, you have to provide it SSH parameters. Or WinRM if you're on Windows. And then also there are some other ones like the Azure target. You provide it with like your subscription ID and some other login parameters, and it can go test resources for you there. Okay, we made it. I'll stop talking. Just kidding. I'm still going to keep talking. But let's start with our demo. Bear with me, this resolution is horrible. One sec. All right, we're getting there. Holy cow, this resolution is bad. We can start to see that a little bit. So first, let's get the mystery out of the way. Let's just see what an Inspec test looks like. So I have a little VM running locally, which we'll talk about in a little bit. So first thing that we're going to do is, since I have my VM running, we can easily generate a Inspec profile. Remember, profiles are what you execute. It's your collection of tests called controls. So we can do this simply with Inspec init profile, and we'll name this successful profile. And what Inspec does, as you can see, is it scaffolds out your profile for you. You've got a few directories that it created. The important ones that we're going to talk about mostly today are this controls directory. This is where your tests are. Remember, those are called controls. And then there's another file called inspec.yaml that we're going to look at in a little while too. But for now, let's run a test. So we have inspec, exec, execute, the profile name, successful profile, and then we pass it our target, which is SSHing into this machine. So luckily, because we created a new one from scratch, that profile comes with a few tests that we can just use for fun or for testing purposes, and that's what we're doing. So you can see here that we ran the successful profile. It's labeled right here as a successful profile, and we ran 2 checks, even though there's 3 check marks. This is just the group passed, and this is the individual test itself. So there's 2. Both of them actually check the temp directory. So let's take a look at this code. Some of the mystery. So successful profiles, control, and the example.rb is what it comes with. So you can see here, again, it's the same test, the same one that we even had in the presentation, just checking the temp directory. The reason that Inspec includes these 2 is because what they're trying to show you is that syntax can be a little different. So you don't have to have this control structure that they have here on the bottom. But I'm going to argue that you should always have it. I won't get into, well, I can get into a ton of the details as to how, but essentially it gives you a lot of benefits. Namely, when you're sharing profiles, it makes it easy to exclude a specific test that you don't want to run. If you're importing, if you're sharing profiles with other people, using the control structure allows you to exclude it. So real quick, let's see what a failure looks like. And no, I don't mean me, Mom. Okay. All right, so I just generated a new profile called failing profile. And then I have a snippet here using everyone's favorite Streamline editor that's going to bork our test. So now let's, oops. Distract. So we're going to run the same inspec exec, except we're going to change the profile to failing profile. How could this happen? Anyways, you can see that what inspec is trying to test here is for /temp/dir doesn't exist. And on this VM image, it does not exist. So it's letting us know. Now, when we put this kind of testing in a CI pipeline, what this will actually do is fail the pipeline, which is awesome. That's what you want. So you know when your tests are failing. So we've seen some kind of examples, some kind of boring tests. Let's see, what would it actually look like if we ran a real test suite? Well, the image that I'm using here, the VM that I'm running rather, is using an image baked by Packer that installs HashiCorp Vault. HashiCorp Vault is a tool that can manage secrets for you, so passwords for applications. You do a whole bunch of other stuff. So I have a test profile that I wrote that tests HashiCorp Vault, so I'm going to execute that against this VM. We do. And it's located in a separate directory, so we'll go to images, tests, Packer, Vault. That's the name of the profile. Huzzah! Uh-oh, one failure. That's okay. So what we have here is quite a few tests that ran this time. I think there's like 30 tests or something. We're checking for a lot of different things. We expect a group named Vault to exist. It does. We expect a user named Vault to exist. It does. We expect a user named Vault to have a group that should equal Vault. It does exist. Woohoo! It's all great. And then you can see a lot of other things. We're checking that a service, a unit file exists. We're checking the mode of that file to make sure that it's going to run properly when systemd starts it. We're checking down here that a whole bunch of packages get installed, JQ, Azure Client, GCC, lots of other stuff. But there is one thing that looks very different from the last profile that we saw run. It's kind of hard to see since it's not on the same screen, but it actually ran 2 profiles, one called Vault, one called Common. Why did it do that? Well, let's take a look. So if we go and look at the controls for the Vault profile that was under Images, Tests, Packer, Vault, if we look at these controls, we can see here, we see many things that look like the test that we've seen before. Control, then we have some describe statements in there. These are all easily readable tests. But then there's this weird thing we haven't talked about yet. Include controls, packer, comment, that's weird. And then this other thing, skip control, telegraph comp, what's that? Well, you remember the inspec.yaml file that I mentioned earlier? Let's take a peek. So under the depends section, we now have something called packer comment and then a relative reference to another directory. Well, here's .. comment, that's right here. What this is this is another profile that is shared among multiple applications. So instead of rewriting it every time and managing it multiple times, we can just reference it in our profile and reuse it. This is great for teams sharing code, and it doesn't have to be a relative link. I'm using a relative link here because that was easy for this demo, but you can also put like a Git reference in there, which is kind of cool. So you can put your profile in a Git repository, or another team manages it in their Git repository, and all that you have to do is slide in the URL here, and Inspec will download and run that profile as long as you have that include statement, the include controls, and this depend statement. There was one other thing in here though that I want to take a look at. So there was something called skip control telegraph comp. What's that? So let's look at this control, comment.rb. There's a test here called telegraph comp. What this is essentially saying is skip that control when you run it. And if we look down here at the common profile, you'll see that there is none called telegraph comp. So yay, it works exactly how we expected. Isn't that great? That never happens in tech. So, many of you keen eyes out there have noticed, and I've kind of given the secret away already, that we are actually executing against 127.0.0.1. Why are we hitting localhost when we're building cloud images? So what I'm going to show you is a nifty little feature that I found. So we've already kind of talked about Packer. I know it's a new tool for everybody, so let's try and describe what Packer does a little bit. Let's do it looking at some of the Packer code and how this has helped me get a local environment. So if we go to, let's close all these out. Actually here. So I've got this command called, or this file called buildvault.json. So Packer, to oversimplify this tool, does three basic things. It takes a source image, so in this circumstance, a Linux base image. It runs what it calls provisioners against it, which really is a fancy term for just configuration changes. In this circumstance, it's a bunch of bash commands that we're running against it. So it takes the source image, makes changes against it, and then it publishes it to a location that you provide. Now, mapping those three things to the actual source code itself, we've got some variables defined up here. That's pretty easy for people. Then we've got builders. Builders are where you tell Packer where the source image comes from. So let's look at that. We've got, this is how Azure structures it. So this is the Azure builder here. And we're actually just grabbing from Azure a CentOS 7.5 box. And then what we're doing is we're running, some of this stuff. We're running these provisioners against it. And these aren't magic here, guys. We're just doing, like, we're creating some directories, we're moving some files to those directories, we're running some scripts, we're downloading packages, things that we all do most of the time, hopefully not by hand, but this is codifying this stuff for us. And then when it gets done with that, we actually run some tests, which is cool, and then it throws it into Azure, and then it becomes useful. So if all of this from Packer is for building cloud images, how am I using it locally? Well, it's quite simple, actually. You can just add this little stanza here. It's another builder called Vagrant, and you tell it we want a CentOS 7 box, and then it will take all those provisioners, those configuration changes, and instead of writing it to the cloud, it's going to write it locally. And then all that you got to do is run like 2 Vagrant commands, which are all documented in the README. Basically, Vagrant, use this image, and then provide me with a VM, and boom, now we have a whole VM that was able to be spun up. And this takes 5 minutes. This job writing to Azure, depending on the time of day, don't laugh, that's Azure for you, but depending on the time of day, it's anywhere from 20 minutes to 37 minutes to complete. So being able to do it locally saved me a crap load of time, because often when you're doing these things, you know, you make little mistakes here and there, and you've got to make tweaks, And being able to spin up a new image in 5 minutes is way, way better. The one thing that I'll mention though about Packer, if you guys start getting using it, is that whenever you run the, it's called Packer build. So you'd say Packer build vault.json or build-vault.json. Whenever you run that, it's going to try and run every builder. So it's going to try and build your Azure image, and then it's also going to try and build your local Vagrant image. You can throw it the -only command and then specify the builder that you want to use. That's how I built this one. I just did -only Vagrant, and then it just builds this one. And when we get to my CI files, you'll actually see that we're using Azure because that's the name of this builder here. So, one other thing I want to show you about the only flag that I just mentioned is that it can also be used here in the provisioners. So if we look down here, I'll focus on this one. So we have a provisioner that's type Inspec. Inspec is the testing tool that we're using, and we are passing it the profile and then a couple of commands here. Believe it or not, this is obnoxious, but you need to tell Inspec that you accept the chef license the first time you use it. It's obnoxious, but get used to it if you're going to use the tool because it's going to cause a pain in your butt like it did mine. So just like what we did with the local command, we tell it the profile test packer vault, but this time we're only running when we run the Azure builder. So that's just another highlight for the only command itself. Okay, so speaking of CI, let's take a look at some pipeline files. So now we're looking at Azure DevOps. Azure DevOps is the CI tool that Azure provides you. You can say positives and negatives about Azure, but I will give them props. Azure DevOps is a great tool. You can take almost the same file that I'm going to show you here and use it in almost exactly the same format in other CI tools like Circle CI or Travis or GitLab CI or whatever it is that you want to use, whichever works for your organization. But I've got 3 pipeline files here that we're going to go through. 2 of them, these are the names of them. 2 of them are Packer. One is called PR, Info Testing Demo. Then we've got Merge, Info Testing Demo. And we've got one called Terraform PR, Info Testing Demo. So let's start with the Packer Info Testing, with the Packer PR one. So we'll just walk through this file. Boy, I wish this was a lot cleaner up here. It's kind of a pain in the butt, isn't it, guys? Well, so what you have here, when you run CI, essentially what you're doing is you're saying, hey, cloud provider, whenever I make a change to this code base and I open a pull request, run this job against it before we allow this PR to pass. So in this example, we're running an Ubuntu box. This is just to do the build, so it doesn't matter that it's not CentOS in this circumstance. We run a couple of dependency installations, so we install Packer so that the cloud VM can use it. We install Inspec so we can run our tests, and we install JQ for various reasons. And then what we actually do is what we talked about at the beginning. We lint our code. So Inspec has a command called check, and this lints the Inspec code. So if I missed any of those end statements, they don't have curly braces, they have those end statements. If I miss any of those, it's going to reject it immediately. Instead of running all this, I was telling you it takes forever, and then rejecting it at the end because your Inspec code is bad. We do it right at the beginning. Same thing with our Packer code. Packer provides us the validate command. We tell it syntax only just to make sure that it's checking the syntax. And then we're telling it where our code bases are. And then we actually get to the meat of this thing. So we run Packer build. We tell it that we only want to build the Azure image because this pipeline is going to publish an image into Azure. And we pass it some variables that it needs, like login credentials, stuff like that, the client ID, the client secret. That's how you log into Azure. And then we tell it the file build vault.json. So that's great, right? We saw that the Inspec tests are embedded into the build-vault.json file, right there at the bottom. It had only Azure and it runs the Inspec profile. So what actually happens is it builds this image, it executes those tests, and if they fail, if any of them fail, it fails the whole CI job. And you know that you've got a problem, you've got to fix it. We don't want to use this code until that's fixed, which is great. That's great rigor to apply to your code base. But then we do something kind of weird. So here we've got a login into Azure, and then we do an image delete. That's kind of strange. So in this circumstance, it passed our test, and we're going through, and now we're deleting the image. Well, why are we doing that? That's kind of strange. Well, remember, this is a pull request. So what I did is in this code repo, you'll have the URL at the end. You can take a look at this stuff whenever you want. I created a fake pull request, and I opened it to try and illustrate the problems that we are trying to avoid by deleting the image. So whenever you're building something in the cloud, or whenever you're running a CI job, blah, 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 we basically are trying to avoid three things. I call them the 3 C's: congestion, confusion, and cost. So when you open your PR, it's going to run your Packer build, right? And then if we published an image and we just left it there, then if you throw a new commit into this pull request, it's going to kick off again and build another image. So if you are going through and you're using these pull requests as you should be by getting code reviews from your peers, then you're going to make changes, right? So you're going to have, just from before your code's even made it into your master branch, you're going to get multiple images. In this circumstances, we have 3 commits here, so we would have had 3 images. You can see that the pipelines ran each time. That's these green little checkboxes. So that causes congestion, and when you have that congestion, there's confusion. Which image do I use? I don't know. Can I delete this image? I don't know. You may have a good tagging strategy to name these things so you know when you can delete them, but that still is going to cost you money, which is the third C. So what we do is we open a pull request, we ask our peers to review it while the pipeline is running, and then we delete that image because while it's in pull request mode, it's considered suspect. But then, after that, we have a second pipeline that runs that looks very similar. This one's called merge. So after your pull request is reviewed, after you've passed your tests, you click approve, you merge your code, it's now in your master branch, and this pipeline kicks off. And you're going to notice it looks very similar, just a little smaller. So we do the Ubuntu machine again, we install Packer, we install Inspec, and then all that we do is we run the build-vault.json. We don't have to worry about linting because we already did that. The tests do run in Packer again because they're baked into the image process itself, but that's okay, it doesn't take that long. So that's a way that you can start with nothing, build locally, and then have tests and verify an image that goes into the cloud. Now let's take a look at Terraform. So how do we do this with Terraform? How do we inject testing into our Terraform pipeline? So for that reason, I have some Terraform code that I've mentioned builds a HashiCorp Vault instance. The things that are involved in that, all the code's up there so you can see. We build a VM, we build a load balancer, we put in a security group so that we can tell it, allow this port but not these ports, that kind of stuff. All of this is in the test repo. I'm happy to show you as well if you're curious. But whenever we have a PR opened against this repository, another job is also kicked off called Terraform PR. This also runs an Ubuntu image, and it's a little different. We install Terraform, we install Inspec, we perform linting again. That's called Terraform FMT funct. And this is going to, again, it's going to reject if your code doesn't either match the syntax validation or if your actual Terraform files are bad. If you have like the wrong syntax in there, it's going to actually reject it. And then we actually execute Terraform. So for those of you who have done it before, Terraform init is what allows us to write to the Terraform state file, which we have in the cloud. And then we run Terraform apply, which is actually going to build our resources. So in this code, we've got 2 different sets of resources that we want to build. The first is networking resources. So I mentioned our security group, our subnet, all of our networking that we need. We build that first, and then we cd into a different directory called Vault, And this is where the magic of Vault comes in. This is where it's building your virtual machines. This is where it's applying some of the other things that are needed to stand up HashiCorp Vault, just to simplify. And this requires a whole bunch of different parameters that we can bake into here, like we want a load balancer type public, which normally you wouldn't want for a tool that manages your application secrets, but for this circumstance, it's okay. I should mention that all this code, I've said this a bunch of times, this code is available. Don't use it. I mean, you can use it for testing and playing around, but don't stand up HashiCorp Vault using this tool, please. So anyways, we go through, and what this pipeline is doing, I should have mentioned, is we're actually, we're building this code in a sandbox environment. So we have like a little sandbox in Azure, and it's building a whole HashiCorp Vault application in this little sandbox. And why do we do that? So that we can do this. One, so that we can make sure that our Terraform code ran correctly. And then two, so we can actually run another Inspec profile against it. So in here, we've got Inspec exec, and then we're putting it to another profile called health check. Let's take a look at that real quick. So this one was under Terraform tests. This is the health check directory. And then we've got this http.ruby file. So we're only running one test here. This is pretty simple, basic stuff, but this is running basically a curl command against the Vault endpoint. So we create Vault, we get the IP from it, and then we run sys, and then we run against HTTP, the IP at port 8200, which is the port that it uses, and then sys health. And all that this does is it gives us a little response back whether or not Vault is healthy and usable. So what you can see here is that this stuff actually runs, and it's kind of cool. So if we look at the last CI job that ran for Terraform, we can see, I don't know if you remember the names of all the tasks that I had, and that's okay if you don't, but we can look all the way down here. We run install inspec, we run the Terraform format, we do Terraform Vault, and then we run the health check. And if we look right here, it's actually running our inspec profile. This looks very familiar, health check. And then even though it's in red, we can read, hopefully, and we had a successful control run. So we have a working service. Last but not least, it does do a destroy of that environment. If your test happens to fail, it doesn't destroy the environment, so you can log in and check why the heck didn't this work, or you can run your test locally against that instance to see what happened. So let's quickly go back to our slides. I'm just going to do it from here. Actually, do you know how to get this back to present really quickly? This freaking format. Here we go. So, remember that story that I told you at the beginning? What had happened? Well, essentially what we were doing is, as we pushed out to our multiple environments, we had the last one to go. We had gone to performance test. We were waiting for the team to do performance tests against our applications before we pushed it to prod. And in that 2-month period that it took, because for some reason it takes 2 months to performance test an old company, one of the libraries that we relied upon got updated. And the new update didn't work anymore. Now, testing would have helped us for 2 reasons. Number one, testing puts you in this mindset where you start really scrutinizing some of these things. You start really learning where are my common failure points. This was a little bit earlier in my career, so I wasn't version locking yet, and now I know you should version lock. You should, if you're not doing it, lock to a version. But then also what you can do is all those CI jobs that I showed you, those pipelines, they can be run on a pull request, which we saw, or on a merge to master. They can also be run on a schedule, and you should do that. It's almost free for you to run these things. So you set these jobs on a schedule, and then we would have seen that library update ahead of time, and we would have seen that failure, and we would have fixed it, and I could have enjoyed my stinking conference. So what next? Well, the whole point of this presentation is to get you to start writing tests, right? So that's my goal. But how do you do that? Well, good question. I'm glad that I asked it. You remember the eyeball test that we kind of poked fun at? They're really, really useful. Arguably your most important test. Write those ones first. Once you're done writing those, write a test for every configuration change that you make. So all of those bash commands that I wrote, making directories, adding files, write tests to verify all those things. Making users, you saw that I had tests for those. Those are important. You need to do it for every change that you make. Third, think and talk about it with your team, and then write some more of those tests that come out. You need to have a brainstorming session. I almost said brainwashing. That's what this is, brainwashing. Have brainstorming sessions, think up other tests, and then write those. Fourth, as you go through this, you're going to make mistakes and you're going to miss things. You're going to think, oh, this is my jam. Oh, these tests are great. You're going to feel like the Hulk. And then you're going to find out that you missed one. Well, immediately write a test for that. Or at least, at the very least, put in a backlog item and get to it in your next sprint. Fifth, seek guidance from your security and your compliance team. I kind of mentioned do this at your own peril because I know that not all of those teams are created equally, but I will say that in my experience, there's always at least one guy with a coding background in the security and compliance team. Maybe you're lucky and you have a lot of those, good for you. But try to find that guy, partner with him, show him this presentation, show him about Inspec, and then, like I said, partner with them. They'll give you a ton of great advice on how to run them. Finally, rely upon external profiles. You know how I mentioned that you can share all of these things? Well, lots of people have. Here's a link to one right here. This is called the Dev Security Linux Baseline. And this has probably 150 tests that you can execute against any of your Linux hosts right now. It doesn't matter which distribution. At least most major distributions you can execute it against. And this is great. This is now an objective, outside verifiable test profile that you can run. And then I also urge you to open source yours. So if you start writing test bases, open source it. It's cool. It looks great for your company. It looks great for you. And then also, you can get feedback from the community. And feedback is how we really grow as open source developers. Lastly, and most importantly, as a takeaway from this, if you start writing tests, never merge code that you could test. After you start this journey, you need to set a strong cultural boundary that if you can write a test for something, you need to. There's going to be a whole bunch of pushback, especially a month or two down the line. People are going to say, oh, well, I don't have time for that. Yes, you do. Because if you have a test base that doesn't fulfill all of your testing needs, then you can't trust it. And that makes it useless, and that's going to make it all die down the line. So be a change agent. Have your manager get your back on this. Write tests for everything. So I'll take questions now. Here's a link to the code that I have, so you can go take a look at it. The slides are up there as well. Somebody already opened an issue against it. I posted in the Inspec Slack channel, and somebody already posted an issue, so I thought that was freaking hilarious. And Aaron, if you're listening to this, good job, thank you. And take a look at the code. There's my email. But I want to hear questions from you guys. What didn't I explain very well? What can I show you code for again? What can we talk through? Or what topics do you want to hear at the next Cloud Native? Thank you.